Lucky from Sri Lanka. We are looking forward to a very interesting webinar today, where Mr. Joseph and Dr. Hans will answer all your questions regarding biogas. We will take the questions in the end. Mr. Dinesh Kumar is here, Senior Research Manager, R&D Center at IOCL. Good afternoon, and thank you for joining us, Mr. Dinesh Kumar. You're very, very welcome in this webinar. We will start in just a few minutes, requesting all the participants to please press the mute button and please keep your videos off. Tanmay Panigrahi is here. Welcome, ma'am, Process Manager. Most welcome to this webinar. Requesting the participants to please keep your videos and audio off so that our audience can see the two speakers and can hear the two speakers clearly. Warm welcome again. Please feel free to introduce yourself in the chat windows. We will be starting in just a few minutes. Thank you for joining us. Just quick introductions. My name is Sachin Agarwal. I'm the CEO of Shrijee. Our other two speakers for the afternoon, Dr. Hans is already here. Mr. Joseph is here. We are all ready for this webinar. And Ms. Tanmay is Process Manager, Kankyo Bird Private Limited. Very warm welcome. Thank you for joining us this afternoon. Requesting the participants to please keep your audio and video off. Dr. Jagdish Kumar is here from Shri Ram Institute for Industrial Research, Delhi. A very warm welcome to you. Mr. Amit Gaikwad from Kirloskar Pneumatic is here. Again, good afternoon and warm welcome, Amit ji. Thank you for joining us. Yeah, we are expecting a very good and informative webinar. The two speakers that we have for you, Dr. Hans and Joseph, are extremely experienced biogas professionals. And I hope, along with all the other participants, to learn a lot from them. Mr. Pawan Gupta is here from BHSL. Thank you for joining and most welcome, Mr. Pawan. So we'll be starting in just a few minutes. Till then, if the participants would like to introduce themselves on chat, it would be very nice because it gives us a chance to see who the various people are. It gives us a chance to know who you are. So most welcome if you would like to do that. If you've just joined us, good afternoon and a very warm welcome. This is Sachin Agarwal from Shrijee. Welcome to the Shrijee JNF Biogas webinar. We'll be starting in just a few minutes. Mr. Ajit Kadam is here from Manjra Sugar Industries. Very warm welcome to you, Mr. Kadam. Good afternoon. Thank you to all the participants for joining us. We are ready for this webinar and we'll be starting in just a minute or 2 minutes. Mr. Sachin Chauhan is here from Atmos Power Limited, Ahmedabad. Good afternoon, Sachin ji, and welcome to our webinar.
Good afternoon.
Once again, requesting the participants to please keep your audio and video off so that sometimes, by mistake, the audio or video comes on and then it disturbs the webinar. So requesting all the participants to please keep your audio and video off so that you can see and hear our speakers very clearly. Mr. Ramesh Chandra Pandey is here from Unique Consultancy Services. Good afternoon and very warm welcome to you. Pragna, I think we've lost Dr. Hans. So if you can just see, maybe he has switched off his video by mistake or audio by mistake. Please see.
I'll check.
Okay. Requesting all the participants to please keep your audio and video off. And good afternoon, everybody. We are just getting started in a couple of minutes. So just give us maybe 1 or 2 minutes more and then we can get started. Pragya, Dr. Hans is still on the party. Yes, there he is. Good to, he's back now. Pragya, maybe you can unmute also Dr. Hans
Yes,
because we are just starting.
I already clicked.
Okay. Hans, maybe you can unmute yourself.
Yes, perfect. Okay.
Yeah, that's.
So with that, Joseph, Dr. Hans, I think we should get started. Welcome everybody. My name is Sachin Agarwal. I'm the CEO of the Shrijee Group. Before we begin this webinar, a quick introduction to Shrijee. Established in 1976, Shrijee has 47 years of experience in the sugar industry. As many of you know, we design, manufacture, and supply turnkey raw sugar mills, refined sugar plants, and now we are also offering biogas plants. In fact, we are building our first biogas plant near Lucknow, and Joseph can perhaps tell you a little bit more about that. Shrijee has a vast experience of doing turnkey projects all over the world. We have clients in 35 countries. Now, biogas is definitely a technology of the future. Along with the correct government incentives, it can be very profitable for the investors and owners. And biogas from press mud or filter cake can be especially profitable for the sugar industry. Not many people know, but the world's leader in biogas is Germany. Germany has approximately 10,000 biogas plants. So we are very happy to partner with a German company, JNF Biogas, and bring that German biogas technology to India. JNF Biogas and Shrijee are now offering you complete biogas solutions. Shrijee will take the order and design and supply the biogas plant based on JNF's German biogas technology. Let me now introduce today's speakers, Dr. Hans Friedman. As I was saying, Germany is the world's leader in biogas technology, and Dr. Hans is the biogas leader within Germany. He is one of the world's most experienced and knowledgeable biogas professionals with more than 39 years of experience in design, construction, and operation of biogas plants. Dr. Hans has worked with many different feedstocks, and very importantly, he has also worked with press mud or filter cake as a feedstock. There are more than 100 biogas plants all over the world which are working on Dr. Hans's designs. He's also a past vice president of the German Biogas Association. Dr. Hans, welcome.
Thank you very much.
I would next like to introduce my good friend Joseph Arulappan. Joseph is a co-founder of JNF Biogas. He has 14 years of experience in clean technology, especially with a focus on biogas. Joseph is an engineer. He also has a master's degree from Sweden. And Joseph is very familiar with the Indian sugar industry because he comes from a family of sugar technologists. So Joseph, welcome to you.
Thank you, Sachin. Thank you.
Lastly, before I hand it over to Joseph, please feel free to send Shrijee your inquiries. We will be happy to discuss your biogas projects with you. we can be reached at sales@shrijee.com. That's sales@shrijee.com. Please use the chat box to ask questions. We will try and answer all the questions at the end of the presentation. So with that, I hand it over to you, Joseph.
Yeah, thank you very much, Sachin. A very good afternoon to everyone. I hope you can see the screen now, full screen. Yeah, so the topic of this webinar is going to be based on using semi-dry fermentation, also called as high-load reactors, for solid feedstocks. What are the advantages of using this specific technology over other solutions available currently in the market? So about the CSTR-based semi-dry fermentation technology, CSTR is nothing but continuously stirred tank reactor, which most of you would be knowing very well. And you might have heard about wet process, plug flow process, like 2 or 3 different technologies. So our specialization is offering something called as semi-dry. Why we call it a semi-dry is because we don't add much water or no water at all into the system for digestion. So basically high organic loading is done into the system to do this, achieve this specific process. And this specific process is suitable for feedstocks like paddy straw, pressed mud, cane thrash, napier grass, and other agro waste. Close to 100 plus plants are in operation across the world based on this technology. The technology was developed by J&F co-founder Dr. Hans Friedman in 2003-2004. And I would now move to the next slide. I would let Dr. Hans explain the conceptualization of this technology and what are the advantages of this and how it can be applied in the context of the Indian biogas industry.
Yeah, thank you, Joseph. The development goal of that technology was to reduce the investment costs, the footprint of the plant designed for these special dry feedstocks. In Germany, we designed this for maize silage, grass silage, and others for the upcoming new renewable energy law in Germany in 2004 by using the right mixing technology to mix also very high viscous digester content. As a result, we have only half of the needed digester size in comparison to the usual wet fermentation process. Half of the digester size means half of the footprint, half of the concrete, of course, and half of the electricity for mixing the digester. That reduces the operation costs. About 50% of the energy costs of operating a biogas plant is only mixing the digester, and that is reduced drastically by the semi-dry fermentation technology. Another aspect of this development was we was able to repower existing plants with our process. We only have to change the mixing system, put a little bit process intelligence in the plant, and we can, without any problem, double the gas output, of course, handling double the feedstock input for existing digester. So that means a drastic increase of profitability and efficiency of existing plants.
Yeah.
That's one of the projects in Ukraine. We made a 5,000 cubic meter digester, 28 by 8 meter diameter to height. You see the mixer inside this tank, very strong, heavy paddle mixer for being able to mix this high viscous material in the digester. This plant was realized in 2020. What you see here is the sampling in my own biogas plant constructed in 2008 using only solid feedstocks like maize, grass silage, triticale silage, grain residues. You see the material is very, very thick, about 17% dry matter. In the second video, you see a mixture of straw with manure digested, also about 17% dry matter. It's pumpable, but you need the right pumps to pump this material from the digester to the other tanks, to the separation system in that case. And of course, the mixer must be able to handle this to get the liquid out of the digester.
Yeah, thank you, Hans. So when it comes to feedstocks, now we will just go through what are the potential feedstocks which can use this CSTR semi-dry process. As most of you would be knowing, filter cake or pressed mud very well, which is a byproduct generated during sugar processing and sugar manufacturing process. So pressed mud has close to 70 to 75% moisture and dry matter of around 25 to 30% dry matter. So if you look at the dry matter, so this is very suitable for this specific process which we are offering. So if you look at sugar mills, fresh pressed mud is available for close to 4 to 6 months in a year, depending upon which part of the country or region. So that's an average availability. For the rest of the year, we need to create, of course, a pressed mud storage yard, which needs to be dedicatedly created for consistency, maintaining the consistency of pressed mud quality. When it comes to gas seals, press mud can vary between 90 to 110 cubic meter per ton of fresh press mud. Of course, this again depends upon your storage methods, the quality of press mud, and your most importantly, your digestion process used also. So the digesters always have to be designed in an optimal way where the maximum gas is generated and complete digestion happens inside the systems. And another feedstock, which is quite interesting currently in India, is Napier grass, which is being talked about a lot in the biogas industry now. So Napier grass again comes from a grass family similar to sugarcane. So Napier grass is a tropical crop that can be grown even in dry and drought conditions. And again, the composition of Napier grass is quite suitable for like let's say semi-dry fermentation process. And again, the same important thing is about always comes to the storage of the feedstocks. How do you store and how do you process and how do you generate gas? Again, the gas yield will depends upon your storage methods, as I said earlier, but you can look around 120 to 130 cubic meter NM³ per ton of Napier grass if it is handled and stored in a right way. So this is one of the very interesting feedstocks which could be a non-sugar industry based feedstocks which could be developed in India if the processing and the storage and the technology, right technologies are used for a successful Napier grass plant. So when it comes to Napier grass digestion process, with our specific technology, there is no pre-treatment required compared to a wet fermentation process where you need to use a pulping machines or some sort of a shredder or a grinder to make it as a pulp and mix it with water and then pump it into the digester. So this is something, really not required to be done for any wet process or dry process in principle, but this is something, which is not required in our specific process. The right way to do this is to make a silo and store it and directly feed it into the feeding system. So in our process, we always use for solids feeding, we always use a solids feeder, which is like a container of 50 cubic meter or 80 cubic meter, depends upon the plant size. So what is the advantage of using this solids feeder? So solids feeder basically eliminates your pulping machineries, your pre-treatment equipments, your agitators, your pumps and everything. So this is a quite straightforward and proven process used across in world and also specifically in Germany. And in our process, we always use a solids feeder because we per se don't use any pulping or pumping with water. So this is one of the advantages of using this process. And from the solids feeder, the feedstock is taken directly into the digester by using a screw conveying system. So the whole pre-treatment and feeding process becomes very compact and very simple and most important, automized in a way that there is a minimal manpower which is required for doing this, the whole pre-treatment as a whole. So cane thrash, next cane thrash, again another feedstock, solid feedstock, which is good for biogas generation. So as you would again know that cane thrash is only available when the cane harvesting is happening for those 4 to 6 months. The storage method, right storage methods needs to be used. And the yield from cane thrash can vary between 300 to 330 cubic meter per ton. Then straw. Straw again is one of the most talked about feedstocks in India, which has been tried and implemented in the last 2 3 years. Many plants are come up or under construction or commissioned currently using straw. So again, straw is a feedstock where the right pre-treatment is required for a successful operation. So I would let Dr. Hans to take over when it comes to the paddy straw, talk a little about straw, and also what are the crucial factors when it comes to digestion of straw and cane thrash.
Straw and cane thrash, doesn't matter which type of straw. That could be wheat straw, rice straw, cane thrash, even all dry materials, if they have a high containment of cellulose, are very good feedstocks for the biogas plant. The bacteria use the cellulose and the hemicellulose to produce biogas. There are some points you have to take care for the pre-treatment and digestion. One point is you must find the right storage way for the feedstock. Baling, keep it dry to avoid biological processes to the material. And before you put it into the digester, you must shredder it in the right way. It's not important to shredder it as fine as possible. More important is the right digestion process, the right micronutrient delivery. This straw is very low in micronutrients, which needs the bacteria to do their job to produce the biogas. And this we must add a very small amount, but very important. It's mandatory for this process. And of course, the digester must work well. We must have the right mixers to keep the material in the digester homogeneous for the whole digester. Another point is the sizing of the pumps and pipes and the selection of the pumps and pipes. With this high viscosity, only a few pipes on the market are able to do the job on a long term in a safe and good way. And according to these pumps, you must size the pipes. That's one of the miracles of the technology we use. If without any experience with these points, the plants won't be successful.
Yeah, and then of course comes the multi-feedstock plants. Again, a multi-feedstock plant is very crucial also, because when someone is planning as an investor, as an owner of the biogas plant, it's always better to think about diversified feedstocks. One might have a feedstock which might be having the major proportion of the mix, but when you're designing the digesters, it's better always to design what could come in future based on the availability of feedstock. So a multi-feedstock digestion process is also best, workable using this semi-dry fermentation process, because the nature of the mixing system we use, which can handle dry matter and consistency in a different wide range. But of course, one has to do the right sizing of the digesters and systems based on the available feedstocks, by at least considering the baseline numbers, what would be the combination of feedstocks for digestion. And the one important thing we would like to touch upon briefly is about storage yard for press mud or any other feedstock. Because what we see currently in India, especially, is storage principles not been kind of applied in most of the plants, because storage is very important for a long-term, as an investment, it might be slightly higher, but for gas yield and maintaining a consistency, like in feedstock like press mud, where there is only availability limited to 4 to 5 months, it is important to have the right storage method and storage systems for using generating a consistent gas all through the year. And also the next crucial aspect is also the gas yield. So perhaps I'll let Dr. Hans to touch upon this point. How do we handle the gas yield part, and how do we measure this, and how do we do the measurements from the gas plant.
The gas yield in the feedstock depends on the composition of the feedstock. The first parameter is the dry matter. The water don't make gas, only the organics. And also the inorganics in the feedstock don't make gas, only the organic. So the organic dry matter is the major part to produce the gas. From this organic part, the lignin also don't make biogas, only the cellulose, hemicellulose, and if it's in other organics like proteins, makes the gas. To get a good gas yield, you need enough high dry matter. Of course, you need enough water that the bacteria can work. In a silage with about 65% moisture, the rest is dry matter. That works very well. If the dry matter in the feedstock is lower than 50%, higher than 50%, you will get problems with the water activity in the system. Then you must add a little bit water into the digester. To design a digester for a feedstock or a feedstock mix for a multi-feedstock plant, we need the data, the characteristics of the different feedstocks, and we calculate for different feedstocks mix how to design the digester. The parameter we need are the dry matter, the organic dry matter, very often the nitrogen, total nitrogen content, and to get the gas yield, we make biomethane potential tests. Normally, I make it in my laboratory here in Germany because then I can compare the results with all the results I got in the last 25 years to be safe for the numbers. In the meantime, we have several results of feedstocks from India too, so we can work on a wide range of feedstocks and we can work with all the 25 years of experience in that factor we have.
Yes. So next is a comparison of a typical CSTR semi-dry fermentation process and a wet process or a plug flow digestion process. So just to give a sample, like an example of how the system works. So if you take a 200 tons press mud capacity plant, we have, let's say the digester sizing by using a semi-dry fermentation would be around 6,300 cubic meter. And if you take the comparative technologies, the digester size would be typically 2x or even 3x times of the sizing for what would be required using our specific process. So which means that one, we are saving the power. Why I say power? Because we are cutting down the number of agitators to 50% instead of having 10 agitators. We are limiting it to 5 agitators in one digester, and we are limiting the civil works because there are 2 digesters. There is a decrease in amount of civil works required. And when I talk about agitators, the main thing comes the power consumption, because your digester side, your power will be technically reduced by 50%, which means that you will have a very good impact on the OPEX of the plant on a long-term horizon of, let's say, 20 years or 25 years of the lifetime of the plant. And next comes the water usage. So with this specific process, let's take feedstock like press mud or Napier grass, the water required will be very minimal, say maximum 10 cubic meter with a consistency of 75% moisture and so on. So in other process, what happens is typically you need to mix the water in a 1:1 ratio, 1:1, or you need to recirculate the slurry back into the mixing pit and do it in a diluted up to, let's say, 8 to 10% dry matter to make it pumpable into the digester. So in our process, since we are using solids feeder, we are able to take 18% dry matter, 25 to 30% dry matter directly into the digester. So after the digestion, let's say during the process of digestion, our agitators are able to mix up to 18% dry matter inside the digesters compared to normal mixers, rod mixers or submersible mixers, which can mix only up to 8 to 10%. And also not to talk about the lifetime of the agitators. So choosing the right agitator is very crucial for a plant operations, because our experience has been that one goes for agitator, of course, based on the cost, And we have seen that one has to, frequently change it. There are breakdowns and a lot of maintenance. So you have a loss of revenue of, let's say, 2-3 months or more, because once an agitator breaks down, then the removing it and replacing takes quite a long term, which means there is a loss in plant gas generation and your revenues for the whole process. And also the other advantages, as I said earlier, mixing multiple feedstocks and so on. And in terms of operation and maintenance, so the digesters, like the agitators, have a lifetime of more than 7 to 8 years. So on a long term, you have very minimal maintenance required on these agitators, which are used in our plant. And these are very low RPM agitators, around 10 to 12 RPM, with a connected load of around 15 kilowatt. So this is a very typical process flow for a wet process versus semi-dry process. As I said earlier, let's take a 200 tons press mud or a 200 ton Napier. It's almost the same sizing. So you have in a wet process, you would have 2 digesters of 6,300 cubic meter. And in a semi-dry process, we would have one single digester. So which means that, again, as I said earlier, your power consumption, civil cost and everything is coming down. And also you need, in a wet process, you need to use multiple pumping systems for pumping into the digester and mixing pre-treatment or a mixing specific portion which has to be done before pumping. And also in some feedstocks like press mud, due to the nature of press mud, it's very difficult to separate the solids and liquids. And one has to use a decanter, for example, for doing the separation, which is of course a high cost and high investment also. So I would let Dr. Hans to touch upon briefly about this usage of decanters in a press mud scenario, and also how we could solve this with our specific solution.
I was working in a Brazilian sugar plant from 2010 to 15, digesting press mud and all the other feedstock you can get in this sugar mill, from cane trash, press mud, spent wash, bagasse. The plant was designed for press mud in mixture with spent wash. First problem, the press mud is easy to store, but spent wash is much more difficult to store in the big amount you need. So during the off season, we didn't have liquid, so we had to provide liquid for the digester to keep the digester mixable. To do that, we started with standard screw separators, but this screw separators was not able to remove the solids from the digestate. That's too liquid, the particle size is too small. So we tested several types of separators all over the world, about 6 or 7 separator types we tested, and none was working, nothing. So then we added a decanter system, and we tested over months different types of decanter, and we optimized this decanter system. At the end, we was able to separate in a system with 2 serial decanters, the first without polymer, the second with polymer. With some optimizations, it was working to separate the solids and recirculate the liquid into the digester. But the investment cost, and especially the costs for the operation of the decanter, was so high that this decanter section in Brazil that time makes the whole process unprofitable. That was a big challenge. So therefore, we try to avoid using water or spent wash, mixing with press mud for the digestion, but have the high viscosity mixing. We don't need additional water. And one option is at the end, for example, to add ash to the digestate to get a solid fertilizer for the farmers at the end.
Yeah. So this is just a typical example. Of course, for paddy straw and other feedstocks, digester sizes, of course, will be reduced significantly in our process. But in terms of separation in paddy straw and Napier grass, other solutions like solid liquid separators can be used, because each feedstock has its own kind of characteristics. So choosing the right separation system is also crucial in the biogas plants, depending upon the feedstocks being used. The next point is regarding retrofitting existing digesters. Let's say that we also have experience of retrofitting a wet fermentation tanks with our own process by changing the agitators and some other equipments like feeding systems and so on. So even existing tanks or digesters from other existing running plants also can be retrofitted with this specific process. So if someone has two digesters for a plant of, say, let's say 200 tons press mud, they might have two digesters of 6,000. So we can convert this technically into double the size. Instead of 208 tons output, we can convert that technically into 16 tons output by retrofitting with the equipments required to increase the size and optimize the plant. So we would briefly go through some of the experiences abroad and also currently our work in India just to give an idea of our currently what is our footprint here in India as well. Dr. Hans, maybe we can briefly run through the plans, just touching upon few main points in the different feedstocks. So maybe you want to start with this MSW plans.
Yeah, this is a MSW plant near Berlin in Germany. I was operating for 10 years, starting 1997. In 2008, it was totally stopped. We were processing the source-separated municipal waste from city of Berlin, together with slaughterhouse waste, with supermarket waste, and so on. We produced electricity, 1.3 megawatt electrical power, and the heat of the CHP we used to heat a tire factory nearby. On a part of this tire factory, we made the basic design of the plant. The plant was constructed by a big German EPC company, Linde, and we had to operate this for 10 years. After 10 years, the emissions were needed by the tire factory. We had 5 people working there, tire factory 4,000. So that was more important, and the owner of the plant, the city, was stopping the plant and give the land to the tire factory. The second technology in this waste plant was we had an automatic separation of impurities. All the plastics, the stones, the bones, the metals was removed automatically by a pulping system. Okay, the next plant, the Silo plant in Germany, is one of the biggest biogas plants in Germany. We made it 2010-11, and the plant is producing about 1,400 normal cubic meters of biomethane per hour, plus 1 megawatt electricity to provide the plant with electricity and sell a little bit electricity to the grid. It's also a multi-feedstock plant using different types of silage, energy crops like grass silage, maize silage, triticale silage, and so on, grain residues, what they get on the market. The plant is in operation since 2011, very successful. That's the plant in Brazil I was working for between 2010 and 15. The plant was processing a mixture of press mud and spent wash. Additionally, we tested bagasse, we tested cane trash, and so on. But in that plant, we designed only simple submerged mixing system, and that mixing system was not able to handle the dry feedstock like the cane trash. Even the press mud was a challenge. We had to add water, and if we had water, and spent wash as a liquid material to the mixture of spent wash and press mud. I'm not a fan of this mixture. There are several challenges. The one is at the end, the separation to get the fertilizer in solid and liquid form or recirculate the liquid. But even more important is the high sulfur content in the spent wash. If you mix this spent wash with the press mud, you have a big challenge in cleaning the biogas for the CBG production. So therefore, I recommend not to mix spent wash with press mud. That's my own plant. I'm sitting currently in my own plant. It's a typical small German biogas plant with 637 kW electricity production. That's an equivalent of about 2.5 tons of CBG per day. We have this dry fermentation system, small digester, very high loaded. We use a wide range of feedstocks, what we get on the market. Here in that region, maize is not growing well, so we have grass, sylvia, clover grass, grain, and so on, sugar beet residues to produce our electricity. The main income is the electricity selling. We have a local heat grid to supply the industry around the plant, also with heat. About 85% of my waste heat is sold to industry. That's one of the plants we made in the Ukraine in the years between 2018 and 22, before the war started. There, that was a wet fermentation plant for pig manure, 1.2 megawatt when we started. In the meantime, it's 3.9 megawatt by adding one of the dry fermentation digesters, 28 by 8 meter. The green block before is the double-size solids feeder with 160 cubic meter volume to feed the feedstock in that digester. And behind you see the green CHP there to produce the electricity.
Yes. So when it comes to the project execution model in India, as Mr. Sachin, when he was introducing, as he mentioned, Shrijee has a licensing agreement with J&F Biogas for offering this technology in India. So Shrijee will front-end the projects and take the orders and execute the projects on a turnkey basis with their vast experience in setting up multiple sugar and refineries in India and abroad. And J&F would be supplying the basic design and supplying proprietary components for the projects. So the projects will be delivered by Shrijee and J&F to the customers here in India. So to touch upon a little bit about our project references and our ongoing works in India. So we are working with one of the investors or EPC in India on optimizing multiple plants using various feedstocks like paddy straw, cane thrash, pressed mud, and other substrates. So that's an optimization contract we have. That was one of our first projects. And talking about our own projects, Shrijee J&F Biogas projects, our first project of 12 TPD and extendable to 18 TPD, I mean, expansion would be 18 TPD, would be technically commissioned, say, by November this year, at the max by December this year. So our first plan for operations will be ready in India by end of this year. This will be again a multi-feedstock plant using Napier, paddy straw, and other feedstocks available in the region. And this will be located nearby Lucknow, just 20 kilometers outside Lucknow. So this, we will keep all the interested parties informed about the progress of these projects. And other than that, we are also executing close to 4 Napier grass projects in AP and Telangana, which have a capacities of around ranging between 10 tons output up to 20 tons output per day CBG. And there are also several other projects in the closure stage, which we are working with our customers currently in India. Yes, so thank you once again, everyone, for participating in this webinar. And now, Sachin, if it's okay, we can take the questions next.
Yes, go ahead, Joseph. The questions are in the chat, and for some of the questions where if it is not clear, we can even unmute the participant and they can ask it. But to begin with, there are, I think, at least 10 or 15 questions in the chat itself.
Okay. Yeah, so I would go one by one. I would take questions. If there are repeat on the same, I will skip them. So one of the first questions is, do we have any live Napier grass plants in India? Answering to this question, we are not much aware about if there are plants operating on it, but as far as we know, our plants as I said, will be commissioned by the end of this year, which will Napier grass will be one of the main feedstocks in these plants. Does the yield harvest of Napier grass diminish with every year? So this is more on the question on the agri or harvesting cultivation side of it. But based on our knowledge, the Napier grass, once planted or the saplings are laid, so it is almost has a lifetime of a cycle of 7 years. So for the first year, there is a slightly lower yield of the grass. And subsequently in second, third, fourth, fifth year, there is a consistent output on the yield of the grass. Again, in the sixth, seventh year, there is a drop in harvesting, or the yield per acre is what we understand by working with our customers on the specialists in this specific topics. And
Joseph,
yes,
Joseph, sorry to interrupt you.
Yeah.
I think if you go to the chat, right? I think you didn't pick it up from the top.
Okay.
So the first, yeah. So if you just scroll up, the
Right.
first question.
Okay.
You will
Okay. So
see-
I have to just see view more
Yeah.
message. Now I
Yeah.
see. Yeah.
So
Okay.
I mean, you will see my message saying we welcome your inquiries, and then there is the first question is from LRNS10. Can you see that?
Yes.
LRNS.
Okay. Okay. I found it. Okay.
So that's where it starts from. Yeah.
Sure. Thank you. So would you cater only for sugar industry or only for entrepreneurs you would like to do with Super Napier? Maybe I can take that so it's faster, I mean, since continuity. So we do for all the organic solid feedstocks. For example, most of our first projects we are doing are using Super Napier. So we are not limited just to sugar industry, even though we come from a sugar industry background, most of us, but we focus on other feedstocks, and most of our projects which are under setting up our non-sugar at this time. Okay, that's already been answered, sorry. And then we are building plans. Okay, can we use
There's a potential of spent wash for gas generation. What are your thoughts on potential?
Yeah, so when it comes to spent wash, of course is a good feedstock for gas generation, but the challenge is only in India, the treatment of spent wash post the digestion, how do you dispose it has been the challenge mainly with the sugar industries. So digestion per se is not an issue. The most of the challenges comes in the treatment, whether you're going to do an incineration or you're going to do one-time land application or you're going to use a spray dryer. So the challenge is more on the downstream part of the treatment process.
Can we use cane leaf dry or green?
Yeah, Hans, maybe you can take this.
Yeah, cane leaf is like straw, has even a little bit better gas yield than straw. The handling is very similar to straw. So cane leaf is, from my point of view, a very interesting feedstock. We can store it, we can handle it, we have a good gas yield, and we can produce a good fertilizer from it at the end.
Please provide the economics of press mud-based biogas project with capacity. Any thoughts, quick thoughts on economics?
Yeah, I think the best thing is probably if they can write to sales at Shrijee, we can help them with these numbers. I think that would be easier. Yeah.
But like Joseph, just very quickly, because we've been running these numbers a lot. Say in a state like Uttar Pradesh, what is the payback period for roughly? What is the payback?
So typically, the investment per ton of CBG output would cost you around 5 crore Indian rupees for the whole plant with a very good proven technology, with a good teams and good EPCs. That would be the investment required for a plant of let's say 200 tons per day input. So your output would be around 8 tons output. So you would require around INR 5 crores for roughly for 1 ton of CBG production. And the paybacks would be typically 5 years for again in UP, the paybacks are less than 3, I mean, let's say 4 years, 3 years, 3.5 years on account of additional subsidies they have. But in other parts of the countries, we would say around 5 to 6 years would be the paybacks for the project on an average without accounting the manure sales. It's only the gas sales. So different combinations, your financing model, your feedstock cost, your, the technology cost. So there are many factors which come into the play actually.
And just to clarify, Joseph meant and said 5 crores per ton. So if you're looking at, say, 8 tons of gas output, so that's 5/8 of 40 crores, right? So for a 200 tons per day project, you're looking at a budget of roughly 40 crores.
Right.
The next question, Joseph, is which feedstocks have higher biogas potential? I mean, I know you covered this in the presentation, but still very quickly.
Yeah. Hans, you want to touch upon that? Yeah.
Yeah, the gas yield depends on the feedstock, on the dry matter and the feedstock. All the straw type feedstocks with dry matter of 85%, for example, are very similar. They are all a little bit above 300 cubic meters biogas per ton of feedstock. In Napier grass, it's a little bit higher per ton dry matter, but there's a big amount of water in the Napier grass. So if you harvest the Napier grass with very early with 17% dry matter, we'll have less than 80 cubic meters biogas. If you wait until dry matter is about 27-30%, it will increase up to 130 cubic meter. So it depends on the dry matter, but gas yield per ton of organic dry matter is very similar of all these feedstocks, between 400 and 550 cubic meters biogas per ton organic dry matter.
Okay,
The
that's per
next,
ton organic dry matter, not the fresh
Yeah.
one. Organic dry matter. Okay.
the next question is very specific, Joseph. I don't know if we can answer it. What is the progress regarding the gas grid in central Uttar Pradesh?
No, to be honest, we don't have
We
that
don't, yeah.
specific.
Sorry, apologies. We don't have much information on that. Do you have? I think you answered this, right? Do you
Yes.
have any live? You answered that. Then what is the C/N ratio preferable for mixture of paddy and cane trash?
The C/N ratio is, from my point of view, not so important. It's given by the feedstock, and we must have enough N to supply the bacteria for growing. Shouldn't be too low. If it's too low, it's no problem. Just put urea in and it will work. If it's too high, you will get inhibition of ammonia. If it's too much N, but that's only, for example, if you try to digest chicken litter, chicken manure, hen manure in very high amounts, then you get perhaps the inhibition with ammonia. So only reduce this, put more straw in the mixture, and you have no problem. That's we can handle.
Can we add spent wash in a multi-feedstock digester? What are your thoughts on adding spent wash?
We can do, but we shouldn't do.
Okay. Because of the effluent issues related to
Yeah.
the spent wash. What about the question on the feeding ratio of Napier grass with cow dung and paddy straw with cow dung? Any thoughts on the ratios of the
Is
ratio?
cow dung needed in the feeding, when you're using
Yeah,
Napier grass and paddy straw is, yeah.
yeah, that's also a question, correct?
Yeah.
Is cow
So the
dung
cow dung we need only for as supplier of bacteria for the biological commissioning, nothing else. After that, we don't need. Only one time, filling some 100 cubic meter into the digester, then let the bacteria grow the right way. In my plant, never was cow dung. I never used, all the 16 years in operation now, I never used cow dung as feedstock or manure. It's not necessary because bacteria are growing on the feedstock. We only supply with micronutrients to give him all the parameters they need for good growing.
Okay, the next question is on the viscosity factor. So please highlight the viscosity factor for paddy straw based digestion, and what is the ideal viscosity that should be kept into consideration?
Yeah, the ideal viscosity is a viscosity we can handle with the mixer. So that's not a number, because we have a three-phase mixture in the digester. We have fibers, we have liquid, and we have gas. Even to measure the viscosity is very difficult, nearly impossible in this three-phase mixture. So what we are doing is we measure the electricity consumption of the motor of the mixer, and that's our signal to add liquid if needed to dilute to keep it mixable. So we have at the end, we have the separation, we remove the solids, and the liquid from the separation will recirculate in amount we need to keep the digester mixable. If we have straw, we also have to add additional water. If we have silage, Napier grass, we don't need water and we don't need recirculation. That's individually designed for the plant.
How do you calculate BMP?
BMP is not calculated, it's measured. There is a regulation, there is a German Engineers Association guideline, which defines the way to measure the biogas potential of a feedstock. It's a very clear batch test, needs about 6 weeks to get the results. We made this guideline in 2004 to make a standard for the BMP tests, because that time in Germany, each laboratory had its own test and you couldn't compare the results. Therefore, we made the guideline. I was one
Joseph,
of the writer of the guideline that time.
and I have a follow-up question. Where in India are BMP tests conducted?
The BMP tests are conducted normally in specific labs. There are labs in IIT Varanasi. There are labs in private labs in, let's say, in Delhi, and also some of them are in Hyderabad, Chemical Institute of Technology in Hyderabad. So there are 4 to 5 labs in India which are available for doing such tests. And more, some of the investors and the companies are buying their own standard equipments and doing this test in-house also to have in-house measurements of BMPs and so on.
Please explain the residence time for CSTR technology. What kind of residence time?
It's a HRT, I guess that's what the question is. What is the hydraulic retention time for a CSTR?
But that's a standard measure. You put a special amount of feedstock in, you have the volume of the digester, then you can calculate the average HRT.
So basically, that depends, I mean, on the feedstock also, your type of digester feedstock and other related details. Yeah.
We need a defined HRT to protect the process. With the effluent of the digester, also bacteria leave the digester. To keep the process stable in the digester, more bacteria or same amount bacteria must grow as bacteria leave the digester with the digestate, with the outlet. And this must be balanced in the right way. That's one point of the HRT. Second point of the HRT is bacteria must have enough time to digest the feedstock. That, especially with straw, for example, needs time. That's a mass transfer problem at the end, if you look in the details. So I recommend to have for straw an HRT above 30 days, better 35 days. For press mud, higher than 20, better 25 days.
Will we provide the bacterial culture? Will Shrijee JNF provide the bacterial culture?
We don't need the bacterial culture. We take by using cow manure. In the stomach of the cows are all the bacteria we need. So we use the cow manure for the biological commissioning, and then you have the bacteria all the time. They will grow.
Any thoughts on how much, just follow on question, how much cow dung is needed at startup?
Depends on the digester size. If you have only a small amount of cow dung, you only will need a little bit longer to get full performance. You need longer time to grow the bacteria. If you have a bigger amount, it shortens the time. But if it's only one ton, it also will work, but will need very, very long time.
Do we prefer submerged agitators or lateral agitators?
We had the picture, the submerged mixer are okay for wet fermentation, very low viscosity. In our system, they won't work.
What type of agitators will be preferable for TS% content up to 18% in digester.
That's
So if the
our
total
mixer.
solids, yeah.
That's our puddle mixer. That's the only mixer I know which is able to handle such material.
And just so this, just a quick word about the paddle mixers or the agitators. They are manufactured in Belgium. Anything else you want to add on that?
That's
The
a very special
special,
system
yeah.
developed more than 20 years ago. Nearly 25 years ago, we started with the development of the mixer. There are some details in the mixer you must take care because this mixer comes in the digester, is installed, and then never touched the next 8 to 10 years. The only thing you have to do sometime to change the oil in the gearbox outside the digester. That's it. So it must be a
Okay.
very, very high quality mixer with all these special designs we need to protect coming digestate into the bearing and so on.
Okay, let me see. In the case of a single feedstock, let's say paddy, how do you deal with the C/N ratio? Because it is very high in paddy straw.
In paddy straw, we will need additional nitrogen to supply the bacteria. There are several chances. The one is put urea in, the other is take chicken manure and mix it.
The second question is, with up to 18% dry matter inside the digester, how will the agitator be able to mix it properly? Which agitator do you suggest for doing this mixing of 18% dry matter inside the digester?
That's the core of our technology, that mixer we saw in the picture, this big paddle mixer covering the biggest part of the digester.
Yes, and I just want to tell all the participants that that is the heart of our technology. And we have the, JNF biogas as the intellectual property on that particular agitator. So the big advantage of working with Shrijee and JNF biogas is exactly this, that this particular special agitator will be made available for your project. During the winter season, how do you maintain the temperature of the CSTR reactor?
Because there is a heating system installed in the digester to keep temperature constant. The constant temperature is one of the most important points for a good digestion. It's not important the level of the temperature. Important is to keep the temperature continuously on the same level on the long term.
For soft copies of today's presentation, please send us an email. The next question is, what is the feed inlet and outlet parameters, the pH, temperature, COD, and solids? The feed inlet and outlet parameters, especially
I think
pH,
this is
temperature.
specific to distillery, I guess, because the question comes from user from the I think it's from spent wash
Premier
probably.
distillate. Yeah.
Yeah. So the feed inlet outlet parameters. This is Hans. This is more of spent wash. What is the feed inlet outlet parameters? The temperatures. Yeah.
So of course we design this for each plant individually. If I have spent wash, we have to cool down the spent wash to digester temperature. Spent wash digestion, I would make thermophilic with 55 degrees centigrade to reduce the cooling capacity. And then depends on the digester technology, the HRT, the fixing of the bacteria, which load, which HRT I would design.
Okay,
So,
I'm going to go a little. Go ahead, Dr.
I think I have lots of experience with spent wash digestion, but there are many companies doing this well. I wouldn't compete with them.
Right. So I'm just going to go a little quickly because we are at 3:30 and there are still a lot of questions. Do you use any enzyme or chemical for dry fermentation?
I do not use enzymes, only micronutrients. The micronutrients are mandatory because there is not enough in. The enzymes are produced by the bacteria if they have available bioavailable micronutrients. That's one of the options. Sometimes you can use enzymes to liquefy more, to reduce the mixing energy. I made tests over the last years, very often different types of enzymes. My experience is also in my plant, I do not use because the costs of the enzymes are higher than the additional gas yield.
The next question is how much land is required for a 5,000 TCD plant? So the question is, a 5,000 TCD plant is a sugar factory. So I think what they're trying to ask is for a biogas plant, which would get press mud from a 5,000 TCD uh,
Yeah, so basically, that's for a sugar mill related. So you require minimum 6 to 7 acres of land, including the storage, the plant per se, the plant and the equipments, and for handling the manure storage and further processing. So around 6 acres of land is required.
What is the typical construction time for a 5 TPD output biogas plant?
It could be, I mean, 10 to 12 months, the whole plant would take for a typical plant.
Including commissioner.
Yeah.
The location of the Lucknow plant, I think at this point we are not able to disclose that. It's just all we are able to say is that the plant is near Lucknow. So sorry, we are not able to share the exact location, but when it's ready, they'll definitely we will, we will tell you more. What is the land and utility requirement for the 10 TPD plant?
Yeah, so that depends again on the feedstock and combinations, because it's a output is what is given here, 10 TPD output. I would say for a 10 TPD output plant, say for a press mud or a Napier grass, you would require at least 10 acres of land for storage, processing, and manure handling, purification systems, and all included in that. And of course, your utility will be depending upon the feedstock and the purification technologies used and so on. So that's, we would be able to give a broader details. So it's not specific to a feedstock or a project. Yeah, so the land would be around 10 acres minimum required for such a project.
But most of the land is used for the storage and the handling of the feedstock. The plant itself only needs a very small footprint.
Yeah, the plant, even for a 10 TPD, you'll require 1 to 2 acres of the max for the equipments and the digesters and so on. Most of the other things are for storage and processing of manure and so
on. They are crushing 12.42 lakh quintals of cane and press mud is 4.5%. What capacity of plant is suitable? How much tons of cane per day?
So this would be, I think, per group 12 lakhs quintals. So it's around 120,000.
We'll just do the math and come back to that question. Just keep moving. I'm not sure I understand this question. Gruner Napier plant 50% of installed output.
I think someone is just passing on information about some other vendor. Yeah.
Okay. What about using this technology in beet sugar industry to utilize the press mud waste from beet, not from sugarcane, to produce biogas? Is it still profitable? So Dr. Hans, fortunately for us, is from Germany, where they do have beet sugar. So Dr. Hans, any thoughts on that? This is from our friend from Egypt, where I also know that they have beet sugar.
I'm processing sugar beet residues from a sugar plant nearby here. It's working very well, and it depends on the costs of the sugar beets. And I do not know the cost. In my plant, 50% of the turnover is costs for feedstock. And if feedstock becomes more expensive, the plant becomes unprofitable. So it depends on the costs of the feedstock. I assume it's profitable in Egypt, especially.
Right. So if you're not getting a good value for the beet pulp, then you may consider this. Any idea on the prices that are being offered on the Napier grass per ton to the farmers? I think there is a wide range, right, Joseph,
Yeah,
on
so
this?
this is something, the customers normally are looking at, but we can't give any specific concrete numbers since we are not dealing directly with
Yeah,
this. But if you want a range, we can say between 900 rupees per ton up to 1,400 is what we hear. So, but that's again, that should come from the people who are actually, harvesting and doing this.
correct. I mean, and again, to sort of emphasize what Joseph said, this is the sort of thing that our clients deal with. So we have no first-hand knowledge of what prices they are paying their suppliers. The storage conditions of press mud needed to achieve consistent yield during the off season. I think it was covered in the presentation, but still, if you quickly want to repeat how to store press mud during the off season.
Yeah, the fresh mud must be stored like we use the maize or silage. We produce press mud silage. It must be stored in a proper silo, covered to avoid oxygen coming in, to avoid composting processes, because the composting process would destroy the energy in the press mud. And in the press mud, then lactic acid fermentation happens. The pH drops down a little bit and stabilizes the material, and then you must handle it in the right way. It's quite simple, like I'm doing my own plant, and we did in Brazil. You saw the picture of the Brazilian storage yard for press mud. That was a very big one with about 40,000 cubic meter volume.
I think the next question is related to the digest state, right? Because it says, what is the feasibility of the waste from the above plants or the end use of the waste from the above plants?
Yeah, so
What can
that
we do?
would depending upon the sizing of the plant. So that's on the mass balance of the whole plant. So that's specific to a case. It will vary, but we could always, if they could write to us and with a specific case, we can help them answer that. Yeah.
How is the problem related to the aggregation of H2S and NH3 addressed? Problem related to the
Related to
aggregation.
hydrogen sulfide and ammonia is addressed. That's the question.
Aggregation.
Both is no
Right.
problem. You must take care on it. The H2S must be removed to have a clean CBG at the end. It's only a question of technology. The ammonia would inhibit the biological process if the concentration is too high. That's a part we handle during the designing of the plant.
Okay. Please explain distillery spent wash based biogas H2S purification to produce CBG. This is, I
Yeah,
think, a question on purification.
yeah. So mostly for a spent wash H2S purification, in India, the levels are quite high, up to 3 to 4%, 30,000 to 40,000 ppm. So the solutions or a biochemical purification is one of the options. Where the OPEX is quite, lower compared to the other process. So this has at least has been our experience. Of course, there is chemical scrubbing. There is other types of process which are used like a combination and also iron leachate, liquid leachate based thing. So, but from our experience, we would recommend a biochemical scrubbing for such a hydrogen sulfide purification. Even biological scrubbing is possible, but the loads are quite high, the H2S, so we need to take care of the process. Yeah.
Okay, so because we are running out of time, I'm going to sort of just go a little quickly. So some of these questions are actually comments, which may be quite useful. So I hope all the participants take a look at some of these comments rather. How much COD load can bacteria in digester? I'm not sure what they're trying to ask. How much COD load can the bacteria take in the digester?
So in our system, I know the COD load only from the wastewater plants, anaerobic wastewater plants like paper industry or so. The highest I ever handled was 30 kilogram COD per cubic meter per day. But this type of plant, they are very high. We talk about the load of organic dry matter. and we go up to 12 kilogram organic dry matter per cubic meter per day. The highest I was operating was 18 kilogram ODM per cubic meter per day.
There's a question from Sri Lanka about the possibility of using palm oil mill waste mixed with paddy straw or palm husk.
Yeah, palm oil mill effluent, empty fruit bunches, and so on are interesting feedstocks for biogas plant, but this must be designed individually to the plant.
There's a question from Syntec Pumps. They are quite a well-known pump manufacturer. Will all the pumps used in the process be positive displacement pumps?
Positive displacement pumps. I do not know this phrase. We have screw pumps, monopumps, which are specially designed for this very high viscosity and this three-phase mix with fibers, liquids, and gas.
Let me see if they're still here. We can.
So, Sachin, I can just take maybe one or two questions which are quite,
Okay, go ahead. Go ahead. Yeah.
So the question is regarding paddy straw. So has there been any scum formation in the digestion of paddy straw is one question. And another question related to paddy straw is there any issues with flotation of the shredded straw into the digesters, undigested straw? So this is related to paddy straw. So maybe Hans, we can take this question.
The flotation of the paddy straw is a problem of wet fermentation systems, not of our system. On account of the high viscosity, we don't have flotation, and we also don't have sedimentation in the plants. Only during the commissioning, when the liquid is in the water is in digester in the first month, we have a little bit flotation, but that doesn't matter because the mixer are able to handle this.
Okay.
Sorry.
So, can a vertical movable submersible agitator be placed in a closed wet fermentation system? That's, I mean, some of the questions are not quite clear. So
Yeah.
We would,
yeah. And yeah, so I mean, unfortunately, and maybe I think, Joseph, if you take a look, maybe we can do just 2 or 3 more questions. And apologies that we can't do all the questions.
Yeah.
But if there is anything you want to answer, last 2 or 3
yeah,
questions.
so maybe I think I have only maybe one question I see here is kind of, where it's straight, where we can answer. So what is the temperature for a press mud digestion plant inside a digester? Maybe Hans, you can just take that last question.
Temperature in the digester can be between 35 and 55. We designed the digester temperature on account of the location we are. If you are in a very hot region like India, we prefer thermophilic digestion, 52, 53 degrees centigrade. In that case, we don't need digester cooling, only a little bit heating in winter.
Okay. Joseph, I guess.
Yes,
Sachin,
yes.
we can give one question. Sachin, this Madhu here from Carl's group.
Okay, one last question. Go ahead.
Yeah, sorry. Thanks very much. See, this regarding because we are having a lot of land here. For Napier grass plant of say 10 TPD biogas output, how much land is required for Napier grass growing and using it as a feed for the biogas plant? Let's type the question also here.
So we can give you just a ballpark number on harvesting this, since it comes on harvesting part from whatever information we have from our customers. I can tell you that 1 acre of land would give you between 120 to 150 tons of Napier grass in a year. That's in a year. So based on this, you can back work on the acreage required. So there are basically 4 cuttings, average 4 cuttings in a year. So 4 cuttings, 1 acre gives you 120 to 150 tons of grass. So based on that, you would be able to calculate the overall land required for.
So per 10 TPD gas, how much is required per day? For 10 TPD.
For input, you would require close to 200 tons of grass.
Okay.
Yeah.
Understood. Yeah.
Thank you.
Moderator, can
Uh,
Okay.
Okay, so with that, let's bring this to an end. Apologies if your question was not answered. We tried our best. I'm really sorry if we couldn't get to your question. A big thank you, Joseph. Thanks for making the time. Dr. Hans, thank you so much for your time and for your presentation. And to everybody, thanks for attending this webinar, for making it a success. Please feel free to send us your inquiries at sales@shrijee.com, and we wish you the very best. If you are in the biogas business, please feel free to reach out to us. We'll be happy to work together with you. So thanks again. Thank you.
Thank you, everyone. Thank you, Sachin.
Bye-bye.
Bye.